Course agenda. Next, let's take a look at the course agenda. 1. Logic Design Fundamentals. In this chapter, we will cover basic logic gates, full adder example, simplifying logic functions with Boolean algebra, simplifying logic functions using Carnot maps, designing with NAND and NOR gates, hazards in combinational circuits, types of flip-flops, Mealy sequential circuit design, design of a Moore sequential circuit, state equivalence and optimization in sequential circuits, key timing considerations in sequential circuits, tri-state buffers and their role in digital circuits. 2. Introduction to Verilog. In this chapter, we will cover key concepts in digital design, hardware description languages, HDLs, levels of abstraction in HDL design, benefits of using HDL, roles in HDL-based digital system design, challenges in adopting HDL, key features of Verilog language, basics of Verilog module declaration, Verilog module hierarchy and instantiation, port connection syntax in Verilog, connecting ports in module instances, using procedural constructs in Verilog, synchronizing module behaviors, naming, rules, case sensitivity, and commenting in Verilog, simulating HDL designs, compilation, libraries, and elaboration. 3. Verification techniques. In this chapter, we will cover key points of simulation in design verification, evolution of RTL simulation techniques, accelerators and emulators in RTL design, debugging and performance profiling, maximizing regression efficiency, hardware debugging and simulation performance, simulation sequencing in Verilog, simulation evaluation methods, RTL simulation optimization techniques 1, RTL simulation optimization techniques 2, register initialization methods, simulating tri-state buses, assertion, monitors in two-state simulation benefits. 4. Verification strategies. In this chapter, we will cover specification and design decomposition, RTL implementation and synthesis, directed testing, random testing, transaction analyzer, chip initialization verification, synthesizable test bench approach, orthogonal verification principle, ad hoc and programming code metrics, state machine and user-defined metrics, fault coverage and regression analysis, event-based monitoring, assertion checkers. 5. Verilog constructs for verification. In this chapter, we will cover data types, real, time, and real-time, case equality operators, procedural continuous assignments, force and release, loop statements, while loop statements, forever and repeat, named events, event and dash, level-sensitive event control, wait, parallel blocks, fork and join, advanced concepts of parallel blocks, initial and always constructs, disabling tasks and named blocks, disable. 6. Design behavior and RTL modeling. In this chapter, we will cover levels of abstraction in Verilog, comparing behavioral and RTL modeling, bus interface controller model, bus interface controller implementation, combinational and sequential logic, bus interface controller RTL, test bench types, test benches with file I/O. 7. Using system tasks and functions. In this chapter, we will cover displaying messages, $display and $write, formatting text output, format specifications, escape sequences in format strings, displaying messages, $strobe, getting simulation time, $time, $stime, $real time, displaying messages, $monitor, formatting the time display, $time format, opening files, $fopen, writing to files, $display, $monitor, $strobe and $write, file input, $readmem and $readmem, file input data format, enhanced C-style file IO1. Enhanced C-style file IO2, simulation control, $finish and $stop, passing real numbers through ports, getting command line values, dumping value change data, VCD, VCD signal selection, $dump vars, dumping extended value change data, EVCD, checkpointing the simulation, $save and $restart. 8. Generating stimulus for testing. In this chapter, we will cover simulation inputs and outputs, simulation process, organizing the test bench, using hierarchical names, generating clocks, generating stimulus, incremental testing approach, generating inline stimulus, generating stimulus using loops, generating stimulus using tasks, generating random stimulus, common random distributions, testing boundary conditions. Worst-case test example, FIFO model. Worst-case test example, FIFO test tasks. Worst-case test example, FIFO. Test sequence, testing protocol interactions. Sweep test example, task definitions. Sweep test example, test sequence, capturing and replaying vectors, resolving vector capture and replay issues, capturing vectors to files, applying vectors from files, vector capture and replay example, model, vector capture and replay example, test bench, vector capture and replay example, capture. 9. Test bench development and application. In this chapter, we will cover design verification challenge, design verification plan, design verification goal, system-level test and configurability, system-level test and communication, completion criteria, coverage metrics, code coverage example, arbiter model and test, code coverage example, block coverage report, managing design space, testing design regression, self-checking test. Self-checking test. Example 1. Self-checking test. Example 2. Test configuration using source code. Constructs. Test configuration using source code constructs. Example. Test configuration using runtime scripts. Test configuration using runtime scripts. Example 1. Test configuration using runtime scripts. Example 2. Test configuration using microcode. Test configuration using microcode. Example. Test configuration using the PLI. Test configuration using the PLI. Example. Script-driven test bench overview. Script-driven test bench in Verilog 1995. Script-driven test bench in Verilog's 2001.